Hello everyone. In this video, we are going to discuss the gravitational acceleration and its value at certain height h and the value of gravitational acceleration in depth into the earth at some depth x and the value of g ultimately at the center of earth. Let's start. Here we have a mass m, the object of mass m at the distance r from the center of earth, and we know that according to the Newton's gravitational law, there will be the attractive force between the earth and the mass m, and which is equal to the F is equal to the capital G, the small m mass of the object, and the capital M mass of earth, and divide by the distance between these two objects, and which is equal to the small r and square, which is Newton's gravitational law. The gravitational force is also equal to the weight of the object, which is equal to the mg, and small g is a gravitational acceleration, where the capital G is a gravitational constant. And now capital G, small m, capital M divided by small r square. The small m mass of the object will be the cancel out from both sides, and then we will get the value of small g, the gravitational acceleration, is equal to the capital G, capital M, and divided by r square. Now we will find the value of the g at the certain height h, and we will convert this value, gravitational acceleration g will be equal to the capital G, capital M, and divided by small r is equal to the radius of the earth plus height from the surface of earth, which is equal to the capital R plus h. The small r, here the small r is equal to the capital R plus h, which is the value of g at height h. And we are if we are interested to find out the value of g at the surface of earth, then the g at the surface of earth, the gravitational acceleration small g will be equal to the capital G, the capital M mass of the earth, and divided by the capital R scale, which is the radius of the earth. If we divide these two equations, then we will get the capital G, capital M, and divided by R plus H whole square, and divided by the capital G, capital M, divided by R square. The capital G and capital M will be the cancel out from denominator and numerator. Then we will get GH by GS, which is the gravitational acceleration at height h, and gravitational acceleration at the surface of earth will be equal to the r square and divided by r plus h whole square. If we common take the common capital R from denominator, then we will get r square into 1 plus h divided by r whole square. The r square will be the cancel out, and gh divided by g of s at the surface is equal to 1 divided by 1 plus h by capital R whole square. As we know that from this relation, our first relation, If we increase r, then the gravitational acceleration will decrease. If we go some certain height, small h, then the value of g will be decreases. And if we take the example here, okay, if we go to the distance h is equal to height, h is equal to the capital R, then if h is equal to capital R, then g of h and divided by g of s is equal to 1 divided by 1 plus h goes to capital R and then capital R divided by capital R and whole square, and it will be the cancel out R plus R and R will be the cancel out, we will get gh divided by g of s is equal to 1 divided by 1 plus 1 2 square, which is equal to the 1 by 4. The gravitational acceleration will be decreased to the 4 times. Now we are going to discuss the value of g into the earth at some depth x. Here we know that the value of g, as we calculate the g, is equal to the capital G and the capital M and divide by r square. If we go into the earth and the depth x, then the value of g will become the capital G and 1 by r square and dm. If we integrate this, we will get the value of g. The value of g is equal to capital G integration of 1 by r square into dm, and dm is the mass of a small object, which is equal to the mass is equal to density multiplied by volume, and which is equal to the dv. The density is constant and it will come out from the integral the capital G and density, and it will become 1 over r square, and the dv is equal to area multiplied by the dr. The area is equal to the 4 pi r square and dv is equal to the 4 pi r square multiplied by the dr, and the dr is negative because we are going into the earth the depth in depth x, then dr is negative. Here we are, now the g will become the capital G density. The integration, this r square and r square will be cancelled out, and the 4 pi is also come out from the integral, and minus also come out from the integral, and we will left with just 1 dr. The integration of 1 dr is minus capital G rho 4 pi, and the integration of 1 dr is just 1, and we will take the limit from capital R to x. The capital R from here is the radius of earth, distance from the center of the earth is equal to the capital R, and we go into the earth, which is the depth small x, and the integration will be taken out of the limits from the capital R to small x, minus capital G rho 4 pi into upper limit x minus the capital R. If we take the minus sign into the bracket, then the capital G, and the value of rho is a density, and density is equal to mass divided by volume, and the mass of the earth is capital M, and the volume, we know that the spherical volume 4 pi r cube divided by 3. 4 by 3 pi r cube. It's the value of density multiplied by the 4 pi and r minus x. This 4 pi and the 4 pi will be the cancel out, and we will left with capital G, capital M divided by r square, and one r will be given to this bracket r minus x divided by r. Now the small g in depth x will be equal to this capital G, capital M and r square is the value of g at the center of at the surface of earth, which is gs, and this will become 1 minus x divided by r. This is our final result. Now finally we will discuss the value of g at the center of earth. If we goes to the center of earth, then our x will be equal to the capital R. Our depth will be equal to the capital R. Then our this result g will be equal to g of s into 1 minus x is equal to the capital R divided by capital R will be the cancel out, and gs into 1 minus 1, and 1 minus 1 will be equal to 0, and the g gravitational acceleration at the center of earth will become 0. I hope you enjoyed this video. Thanks for watching.